Hello guys, welcome back to class. In this session, we'll start with 2D arrays, two-dimensional arrays. Two-dimensional arrays. So we have discussed already 1D arrays. What is one-dimensional array? What it contains? This is actually array of elements, right? One-dimensional array is array of elements. You are storing elements in that. 2D array is array of 1D arrays. 2D arrays array of 1D arrays. So wherever 1D is there, you replace that with 1D array definition, replace that with, so it is array of 1D array means array of elements. So this is array of elements. Array of elements. Or literally you can say it is containing array of 1D arrays. Array of 1D arrays. So what is the motivation for this? First, you see the motivation of one-dimensional array. What we have done in the one-dimensional array? Suppose I have individually a variable is there. A variable which contains the value 10. Then B variable which contains the value 20. Then C variable which contains the value 30. Then D variable which contains the value 40. E variable which contains the value 50. Like this, I have 5 elements. Maybe 5 or 5,000 elements. So when I have individual elements like this, I have to declare individual variables. A variable to hold one value, B variable to hold another value, C for holding another value like this. If I have 5,000 variables, I declare 5,000 variables, tough. For that, individual elements, instead of declaring variables for individual elements, all elements we are combining and keeping in one room, or you say one hotel side by side in different rooms like this. This is an array which is pointing elements. See the definition of 1D array? This is array of, what are these? What are these guys? Array of elements. So instead of declaring, I have 5 elements. When I declare individually, 5 elements will get the memory at 5 different random locations. You keep your friends are staying in 5 different rooms in a 5 different hotels somewhere different. Instead of that, bringing all into one hotel and rooms are side by side 0, 1, 2, 3. So that's how one-dimensional we used. Now 2 dimensions. You can consider an example that suppose in a one batch I have say 200 students. I'm conducting exams. Conducting exam. In exam, you got the marks. 200 students, I'll get 200 marks, individual marks. So how many values I have? How many values I have, guys? 200 values are there. For exam 1, for storing exam 1, I am taking one array. In this array, I have an array of 200 marks I stored. But I am conducting another exam. Exam 2, I have another array of 200 marks. 200 elements, you say, 200 elements. I am conducting another exam, 3, which is again array of 200 elements. So how many arrays I have? How many arrays I have? 3 arrays. One array, this is a one-dimensional array, right? First one-dimensional array, second one-dimensional array, third one-dimensional array. First one-dimensional array storing the marks of the first exam. Second one-dimensional array storing the marks of second exam. Third one-dimensional array storing the marks of third exam. Now these 3 arrays we can combine. These 3 one-dimensional arrays we can combine and keep in a 2-dimensional array. So how it works? Suppose I have int, suppose A equals to new int of 3. What is this? This is one-dimensional array whose size 3. 3 elements, one-dimensional array. How memory will be allocated? A gets memory and 3 blocks will be allocated. Initially, some values will be there, let it be. Defaults are 0. Next, I have another array B, new int of 3. Again, B gets memory. 3 blocks will come, default zeros. And I have another one-dimensional array C equals to new int of 3. Okay, guys. Now, where array 1 gets address somewhere, we don't know. Consider the address as a 500. So it contains a 500 address. Where B is getting somewhere at 600 randomly. So it is containing 600. Where the C getting somewhere at 700, we don't know where randomly. Indexes again 0, 1, 2, 0, 1, 2, 0, 1, 2. So consider A array contains your first exam marks. B array contains your second exam marks. C array contains your third exam marks. I have created 3 one-dimensional arrays. Now these arrays are at random locations. Am I right? How many arrays I created here? 3 arrays. How many names you have given? 3 names. Like this, if I conduct 100 exams to you, 100 exams, 100 arrays I have to create. Yes or no? Again, first array, exam 1, one array, exam 2, another array, exam 3, like this, multiple arrays I have to create. Now, to store these arrays, I can take 2-dimensional array. How it is? So when you say 2 dimensions, the syntax should be like this. Your array name you write, 2 brackets you have to use, and these 2 brackets should be empty always, guys. So left side your declaration, but this is the declaration part. And a new int of 2 sizes you have to write, 2 dimensions you have to write. And as discussed, this is section A, which is a 2D declaration part, and B, 2D object creation, and anyway C is for assigning object address to reference variable. A, declaration, am I right? A is declaration. What is a B? Object creation. A side, declaration side, you don't specify any sizes, like 1D array only. On the object creation side, you have to say 2 dimensions. What are these 2 dimensions we have to provide? A and B. This you have to fill. For this is a 2D array. Why you need 2D array? Tell me in one line, whatever story you understand from introduction part of 2D arrays, tell me in one line, what is the use of 2D array? What is the use of 2D array, guys? No answer till. 2D array is collection of 1D arrays. It means 2D array is for what when I ask? 2D array, can I say it is to store 1D arrays? Am I right? To store 1D arrays. Sadhana, you're right. Pavitra, not values. To store 1D arrays. Purely remember, strictly remember. 2D array is only 2D array not for storing data. Dharani, not for storing data. 2D array is only for storing 1D arrays. Make it super clear. 2D array not for storing data, not for storing elements, only for storing 1D arrays. Why 1D arrays? Why 1D arrays? Why 1D arrays? 1D arrays are to store your elements. Instead of data, use a term elements, guys. Instead of data, use a term elements. Instead of data, use a term elements. To store elements. Remember, only 1D arrays will store data. Only 1D arrays will store data. Java supports multi-dimensional arrays. Multi-dimensional means you do 1D array, you do 2D array, you can do 3D, 4D, practically possible. But in the real world scenarios, you may not use 3D, 4D and all. Maximum 1D, 2D you will use. But you can implement ND arrays, 5D, 7D, 10D arrays also you can implement. But you do anything, only 1D arrays stores the data. Okay. When only 1D array stores the data, my question to you, what a 2D array will do? 2D array is to store the 1D array addresses. Then what 3D will do? 3D array is to store the 2D array addresses. 3D array is to store 2D array addresses. And 2D array is to store 1D array addresses. 1D array only actually stores the data. Is that point clear? First. So from this, okay, you are writing a 2D array. What 2D array storing? Again, my question. What 2D array storing, guys? One D arrays. Can I say strictly addresses of 1D arrays? Addresses of 1D arrays. Okay, 1D arrays. Now, you tell me answer to the first question. A, how many 1D arrays you want? How many 1D arrays you want? Second question. How many elements you want in each 1D array? These two questions, you have to answer it. How many 1D arrays you want? That is your A. That is your A. Your wish. Your wish, right? You can say 0 also, but there is no use. So currently I have a 3 1D arrays, guys. See this? I have 1D array, 1D array, 1D array. How many 1D arrays I have? I think most of you answered commonly as a minimum 2, at least 2. There is no rule that minimum 2, guys. It can be 1 also, it can be 0 also. Your wish. Practically your wish. Any number as per your requirement. Suppose I am conducting 10 exams for you. How many 1D arrays I need? 10 1D arrays I need. Right? Okay. Cool. Now, as per current my project requirement, I have a 3. 1, 2, 3 required. So, the first dimension you are specifying represents A. Represents number of 1D arrays you need in your application. I want 3 1D arrays. Okay. 3 1D arrays you want. Now, second question, guys. How many elements you want in each 1D array? 1D array means you have to say that how many elements you want to store. Suppose here in my first 1D array, I am taking 3. Second 1D array 3. Third 1D array 3. Currently make it as uniform in all. Maybe you may have a variation also. How to handle the variations, we'll do it later. Consider that how many elements you want in each 1D array, guys. Currently, I want 3 only. Second dimension represents that. So is these 2 dimensions clear? What is the first A represents? First dimension A represents, guys? How many 1D arrays you want? Simple. Second represents, second dimension B represents number of elements in the 1D array. Number of elements in the 1D array. Number of elements in the 1D array. If represent as a matrix, guys, which has the rows and columns. So how many rows now? Row 1, row 2, row 3. How many columns? Column 1, column 2, column 3. So if you give 3, 3 here, this also gives 3 by 3 matrix. So the first 3 can also be called as number of rows. Suppose in first array, I have a 10, 20, 30, guys. In array 1, 10, 20, 30. Array 2, 40, 50, 60. Array 3, my elements are 80, 90. How many elements in the first array? I have 3 elements in the first array. How many elements in the first array? I have 3 elements in the first array. How many elements in second array? I have 3 elements in second array. How many elements in third array? I have 3 elements in third array. Like this, how many arrays are there? 1, 2, 3 arrays are there. So when you represent this, each array in one row. How many rows are there? 3 rows. Means 3 one-dimensional arrays are there. Columns, nothing but number of elements in the each array. So you can also say the first is the rows when you represent as a matrix, and second represents the columns, right? Or in general, first represents how many 1D arrays you want in your application. Second is number of elements in each 1D array. Okay, very good. Before drawing the memory representation, I just want to ask you one question. In this line, guys, how much memory will be allocated? Can you say that? Calculate and tell me in this, how much memory will be allocated in that line? Int ARR equals to new int of 3, 3. Quickly calculate. As of now, what I received 28 to 44, 44, 32, 44, all wrong. All wrong. So, as of now, whatever the theory I told, with that theory, you are unable to visualize the 2D array representation, right? 2D array representation. I think I got one answer from Hari as 68. Yes. Yes, Hari, it is 68. How 68 comes, I'll show you. Come back here. Now, first ARR, guys. What is ARR? ARR is a reference variable. Which reference variable? Whether ARR is a hello class reference variable? No. ARR is a string class reference variable? No. What is ARR, guys? Tell me. What is ARR? Array reference variable, right? Array reference variable. ARR is array reference variable. Whether ARR is array reference variable. Okay. How many bytes will be allocated? 8 bytes only. Any reference variable, guys, 8 bytes. And default anyway, null, n I kept. Okay. This is actually 2D array reference variable. This is 2D array reference variable or 1D array reference variable? Two brackets are there. 2D array reference variable. And this cannot hold address of 1D array. I mean, in this ARR, can I store like this? Is this possible? ARR already I declared on the top. Or for your clarity, I am declaring again. See this, is this valid? This ARR having two boxes, two dimensions. This is to store only address of 2D array. But this one box gives the address of 1D array, not compatible. Okay, up to that, make a difference. So ARR is, the point here is, ARR is a array reference variable, 2D array reference variable which holds the address of 2D array only. Done. Now come to these dimensions. What's the first dimension, guys? What's the first dimension? 3. What it represents? What it represents? What 3 represents? How many 1D arrays you want? Okay, 3 1D arrays I want. Okay, but I have to create a memory for 1D arrays. In each 1D array, how much memory required? Yeah, Manikanta, I think finally you got that total of 68. Yes. How many elements you want in second 3 telling how many elements you want in each one dimensional? 3 elements, right? So first you construct a one dimensional array. One dimensional array size 3. This is a one dimensional array size 3, guys. Indexes 0, 1, 2. This is a 1D array only. Simple box. What's the default value of this? Default value, guys. 0, 1, 2. Oh, sorry. 0, 0, 0. Wait. 0, 0, 0. I created a one-dimensional array, size 3. Like this, how many I have to create? You need another one-dimensional array. Like this, you need another one-dimensional array. And these are integer type only. Initially, we are taking as integer, so all zeros. Indexes, this is one-dimensional array. We know one-dimensional, 0, 1, 2, 0, 1, 2. So whether according to the specification, I created 3 one-dimensional arrays or not. I have a 3 one-dimensional array. Yes or no, guys? This is my first one-dimensional array. This is my second one-dimensional array. This is my third one-dimensional array. I have a 3 one-dimensional arrays. And according to the first number 3, I needed 3 one-dimensional arrays. Yes, I created. And what is the size of each one-dimensional array? 3 I want. See, size of each 1D is 3, 3, 3 only. Done. Now, you have a 3 addresses. There is address of first one-dimensional array. Address of first one-dimensional array. I am keeping this as 500. This is 600. And this is 3 addresses I have. Can I store these addresses into this ARR? Can I store these addresses into ARR, guys? No. First 3 addresses are there. Problem number 1 is, if I allow also, there are 3 addresses. Which address you will store? Not possible. First, it is not allowed because these are 1D arrays. These are 500 is the address of 1D array. 600 is address of 1D array. 700 is address of 1D array. But what you can store in ARR? What you can store in ARR? What address can be stored in ARR? What address can be stored in ARR? What address can be stored in ARR? Address of 2D array, right? So, but we have 3 addresses. We can't store one address also, but 3 addresses. For this, we need a 2D array. We need another array, guys, here. This is the 2D array actually. Size is 3 only. Why 3? Actually, first we'll create because I given a 3 arrays required. It will create first 3 like this. tree size. Then it will create a 3 arrays. Now this address will be stored here. 500 will be stored here. 600 will be stored here. 700 will be stored here. Consider this address as 900, guys. Address of 2D 900, that I am storing here. Do you understand, guys, now? Indexes 0, 1, 2. Important for us, this array, guys. What is this array? Is this for storing elements, data? Is this for storing elements? This is the 2D array. Why you're calling this as a 2D array? This whole box is the 2D array. Why we are calling that as a 2D array? Why we are calling that as a 2D array? Why we are calling that as 2D array? I told you in the beginning, 2D array is only for storing addresses of 1D array. Very good, very good, very good, guys. Anybody who is storing addresses of 1D array, that guy is called as 2D array. Clear? What the box is containing? Address 500 is there, address 600 is there, address 700 is there. What is 600? Address of 1D array. 500 address of 1D array. 700 address of 1D array. So this array containing addresses of 1D arrays, that's why it is called as 2D array. If you have 2D arrays like this, 2D arrays addresses, if you're storing another array, that becomes the 3D array. That we'll see it later. Okay, the representation is clear, guys. See now, here I have a 3 arrays, guys, individually. You see, I have A array. To store 3 elements, I have an array and address 500. To store another array, B address, B 3 elements address. See, individually I have, see, 1D array, 1D array, 1D array. These addresses I have to store. Addresses I am storing in 2D array. 2D array address I am storing in ARR. Representation is clear, guys. Any doubts on this? See clearly. Is that clear? Any doubts? Now you calculate the memory. Calculate the memory. So this also I am taking out here. How 68 is coming? This is 8 plus 8, 8, 8. This 3 into 8 plus this is how much? This is 8 bytes, I think, right? This is 8 bytes. This is 8 bytes, right? 8 bytes because it is address of 1D array. Address means 8 bytes. In this 1D array, what you are storing, guys? What you are storing in 1D array? What you are storing in 1D array? Elements. 1D array always contains the elements. 1D array always contains the elements. Okay. In this example, what type of elements you are storing in the 1D array? In this example, what type of elements you are storing in the 1D array? Integer elements I am storing. Integer means how much space you want, guys. 4. How many rooms you want? 3 rooms. 4 into 3, 12. What is the first 1D array contains? What is the size of first 1D array? Size of first 1D array. That is, I have 3 arrays like this. 3 into size of first one 1D array. 4 plus 4 plus. This is 4 into 3. Calculate 8 plus. This is 24. Okay. Plus this is 3 into 12. So 8 plus 24 plus 36. 36, 24, 68. Did you understand? Representation is clear, guys? Very good. No. What ARR contains? Again, I am asking the same question. What ARR contains? What ARR contains, guys? Address of 2D array. Very good. Contains address of 2D array. How many 2D arrays you created in this diagram? How many 2D arrays are there? Only one 2D array whose address is 900. Very good. What is ARR of 0? Contains address of, no, don't tell only address, sorry. One specific address of 1D array. In this special, I am using address of first 1D array. Can I use like that? Address of first 1D array. Am I right? You have, if you want to go to one-dimensional array, this is the address. Address of first 1D array, which is, this is ARR. ARR of 0 means this, which contains address of first 1D array. Right? Address of 1D array, but it is a first 1D array. Now, I want to access the element of, in first 1D array, how many elements are there? First 1D array, how many elements are there? 3 elements. Now, my question to you guys, how to access first element of first 1D array? First element of first 1D array. ARR of 0, 0. Very good. See this? What ARR of 0 is telling you? ARR of 0 tells first array, first 1D array, right? ARR of 0 tells first, up to this means you will get the address of first array. In that, I want to go to first room. So, the second index is index in the first array. I want to come to this 0. For this, how to come from here? Come to 0, 0. First element of first array. And this 0, 1, 2. Understand? What is this? First element of first array, correct? And this is second element of first array. Third element of first array. Clear? We are able to access first array all the elements. Next. What ARR of 1 contains, guys? ARR of 1 contains address of second 1D array, correct? It contains address of second 1D array. When you go to this one, first index is fixed. If you want to access second array elements, so first ARR, first index is fixed as ARR of 1 only, right? Again, first array, second array, this is second array, right? Second array, first element 0. Second array, second element 1. Second array, third element 2. So what is this representing? This is first element of second array. And this is second element of second array. And this is third element of second array. So clear how to access second array elements? Similarly, you can go for a third array also. Third array also, guys. So clear how to declare a two-dimensional array? Declaration part we are done, and construction part, the dimension and importance we understand, internal memory representation we understand. So 2D array is simply collection of 1D arrays, how to access individual 1D arrays, how to access elements of 1D arrays, the index, two-dimensional indexes. Is that clear? Any doubts on 2D introduction part? Tell me, guys. Is that clear, or any doubts in 2D introduction part? Say something quickly. Still we have to discuss some more. Very good. So I'll ask you some questions now. So here I want to assign a 99. In this location, I want to assign a 99. You tell me the expression now. Here in this box, I want to assign 99. Tell me the assignment statement. In which array, which element, like that. Tell me the how to assign. Tell me the code. Here I want to assign 99. Tell me the code for that. Error of. This is which array? Second array means here from this you come to this. For second array from this 1 equals to 99. That's it. And here I want 1, 2, 3. Last box I want 1, 2, 3. Then what is your expression? Error of what and what equals to 1, 2, 3. 2, 2. Very good. And this one 5, 5. First array, second element. Yes, 0, 1. Simple. So I hope all that clear about two-dimensional arrays. Let's start the labs now, guys. So last lab we are done is 2 to 8, right? We'll start from 2 to 9. 2D labs. 2 to 9. Into ARR. Is it a declaration part only? I am making as a static because we are using there. It's a purely declaration, am I right? And printing ARR. What will you print it? Tell me. Only declaration statement, guys. As of now, what memory will be allocated? It allocates only memory for 2D array, array reference variable. How much memory allocation? If only this statement means, for this statement, guys, ARR gets memory. How much memory? 8 bytes will come. What is default initialization? JVM will initialize because of static. Yes, you have a null value. When you print, only declaration. As of now, your 1D array is not constructed, 2D array not constructed. What is declared? Only memory allocated for a 2D array reference variable. That's it. Whether a 2D array created here? No. 1D array is created? No. No array is created. Only declared. That is also 2D array reference variable declared. So this gives simple 229. Simple, done. 30. You have to answer this correctly. 30, guys. I think same null will come. This also will give the null value. Am I right? Error Y. Error Y, guys. is a local variable. Yes. Very good. You remember this point now. Variable ARR might not have, because local variable you have to initialize this. Super good. Next, 231. See this statement, is it fine or okay? Remember here, guys, the new point. In the two-dimensional array, first dimension is mandatory. Mandatory, must, you must write the first dimension. Second dimension is optional. Second dimension is optional. So that point is, make it clear. First dimension mandatory, second dimension optional. So this program will compile or run, compile will compile or not, tell me. According to that, will compile or not, guys? Yes, it has to compile. Now, what is there in this? Okay, it will compile and print the address, some representation. Which representation? Is it two-dimensional representation or one-dimensional representation? We have to understand. Compiled successfully. See this. I'm just bringing this back to this program. So is this a 2D array or 1D array? How you are seeing this? Two brackets are there. See, two brackets, 2D array. One bracket represents 1D array. Two brackets, 2D array. What type of array it is? Integer 2D array. Integer 2D array. So what ARR can hold? ARR is representing address of 2D array only. Address of 2D array. This printed. Now, memory representation we have to see for this. How memory will be represented? Previously, when I give dimension as a 5, first dimension, second as a second dimension. Suppose like this, if I give, guys, what happens? Okay, let me to do this. Suppose I am giving like this, 5 and 2. What happens? Tell me now. What's the meaning of 5 by 2? 5 by 2, guys. How it comes? How many one-dimensional arrays you want? It allocates memory for ARR first. Okay. Then how many 1D arrays you want? I want a 5 1D arrays. So it allocates memory for 5 1D arrays. 1, 2, 3, 4, 5. 0, 1, 2, 3, 4. This is the 2D array, am I right? This is 2D array whose address will be stored here. 2D array created or not? 2D array created, 2D array object created or not? What is size of 2D array? Not memory size, element size. 5. 5. 5. Why 5? It means I want 5 one-dimensional arrays. So memory will be allocated for this. Now, it has to construct one-dimensional arrays. How many 1D arrays has to be created? 5 1D arrays has to be created. What is the size of 1D array? Size of 1D array 2. So I have information. I can create 1D arrays like this. Done, like this I can do. Now, if I am not giving the second dimension, guys, what happens? I'm not giving second dimension. Now what happens? Can you create the 1D arrays now? So 1D arrays will not be constructed. This is the null. This is the null. Because 1D array is not constructed. Why 1D array is not constructed? I don't have information to create 1D array. What information you want to create a 1D array? I want to know how many elements you want in 1D array. If you say I wanted 2 elements, 3 elements, whatever, I can create 1D array. To create 1D array, I need how many elements you want in 1D array. But you did not say that. Second dimension represents the number of elements in the 1D array. Second dimension is not specified. So I don't have an option to create a 1D arrays. Then what error of 0 contains? What error of 0 contains, guys? Because I didn't give dimension, error of 0 contains what? Do you have first one dimensional array constructed? No. Do you have second one dimensional constructed? No. What error of 0 contains? No answer as of now. What error of 0 contains? Null value, because it is not constructed. So what output you are getting? ARR gives the 2D representation. ARR of 0, null, 1, null, 2, null, 3, all null as represented in the diagram, right? Compile this, 231. See, all are null. ARR contains address. Remaining are null. 1D array is not constructed, guys, simply. Why 1D array is not constructed? You did not specify the second dimension. What is the link? Second dimension is the important. Second dimension, not mandatory, optional, but second dimension is linked with 1D arrays. Second dimension represents the number of elements you want in each 1D array. All right, not done. Okay, I'll just do it 132.java. I am giving a second dimension as 3, guys. Now, can you create full array? Can you create one dimensional arrays? Yes, create. You're going to make this as 3 elements, each one dimensional. Like this, how many? 3 size one dimensional arrays, I want 5. Okay. How many data elements you can store in this, guys? How many integer numbers you can store? $15 elements. 3 by 2, 15 elements you can store. These are 15, see. Can I store data here? No. Can I store data here? No. These are all for addresses only. Here you can store 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 rooms are there. Now, what ARR contains? ARR contains address of 2D array. What ARR of 0 contains? What ARR of 0 contains? Now, one-dimensional arrays are constructed. So, ARR of 0 contains address of first 1D array. ARR of 1 contains address of second 1D array. ARR of 2 contains address of third 1D array. ARR of 3 contains address of fourth 1D array. ARR of 4 contains address of fifth 1D array. So, addresses are there. I am printing ARR of 0. It has to print addresses. Let's check that. 32 now. See the differentiation you see, guys. There's a single bracket, one bracket I at some hash code, one bracket I at some hash code. Clear? Okay. To 32 over, right? 33. I'll just take 3 by 3 simple. Okay, so in this, I want to initialize first array. First array elements I want to initialize to 10, 20, 30. how to do initialize first array? Error of 0 and 0. First array, first element is 10. First array means the first is common, 0, 1, 2, 10. So what I did here, guys, first array, 3 elements are there, right? First array, I can store 3 elements. First array, 3 elements are initialized as 10, 20, 30. Print this first array, 10 elements. How to print the first array elements? I can use a loop for int I equals to 0, I less than. Tell me I less than. Currently 3, I am using, let it I plus plus. I want to print first array elements only. First array is a one-dimensional array only. First array is a one-dimensional array only. How to print one first array elements only my requirement. I initialized only first array, right? This is only I initialized first array. I want to print only first array elements. Can you tell that? We have to specify 2 dimensions, right? First error of 0 anyway fixed. Second dimension you have to change 0 I. I value will change from 0, 0, 0, 1, 0, 2, 3, right? That's done. You print it now. First array initialized, first array printed. I'll just repeat the same. Second array I'm initializing. Second array how? This is the fixed as one, right? And I want to make as 40, 50, and second array initialized with 40, 50, 60. What's the change in this? This is 1 comma I. Yes, 1 comma I. Same third array, 2, 2, and 2. This I'll fix it as. And condition you didn't tell me, guys. What is the condition? 3 is hard coding. We should not do that. Here length you have to say. The length you have to say as first array length. First array means error of 0 dot length. 0 dot length is different, error dot length is different, right? First array, error of 0 representing first array. Error of 0's length. First array length means 0's length. And here, once currently it is same only, but explicitly, what is the length of second array? Error of 1 dot length. What is the length of third array? Error of 2 dot length. Is that clear? We have used a for loop to access a one-dimensional array. Again, another one-dimensional array I have. Again using for loop. Again, one-dimensional array. Again using for loop. Right? But if I have again 100 one-dimensional arrays, again same code repeatedly writing a complex, right? First we'll run this. 33. See, all are printed. So can we still reduce? Can we use a 2 for loops? 34, 234 lab number. So I initialized all first. 3 are initialized, 3 are initialized. Now see this. One for loop for printing one-dimensional array. Second for loop for printing another one-dimensional array. Third for loop. Some task I am repeating. Again, this task can I keep in loop? Yes. So 2 for loops for this two-dimensional array. Int I equals to 0, I less than error dot length and I plus plus. And for representing 2D, I will use a J loop. Second, this instead of I, I'll use J. Into J equals to 0, J less than error of I dot length and J plus plus. Here I do say row and column, R, I and J. Okay. Currently for clarity, I am giving 2 brackets separately. See the little bit indentation. Two loops, how 2 loops will execute. Did you get a clarity on how 2 loops will execute, guys? Nested loops, somewhere I explained. Have you studied that? Only one yes I got. This anyway I'll explore further. I think let me to stop this session up to this. It's also printing like this, but further we'll study more on this. 2-dimensional array printing this. We'll see some more labs on 2-dimensional, some more concepts in the next session, guys. Okay, that's about today's session. Thank you. Have a nice day.